Okay, now that I've got my t-score of 2.626, I can find my margin of error. So my margin of error is a t-score times s divided by the square root of n. So that will be equal to t is 2.626 times s is 0.72 divided by the square root of 110. Okay, that will give us 0.180. Okay, now that I've got my margin of error and my sample mean, I can plug that back into my confidence interval. So I've got 98 minus 0.18 less than mu, less than 98 plus 0.18. So that will give me 97.82 less than mu, less than 98.18. And that is your confidence interval for this data set. Okay? In a study designed to test the effectiveness of magnets for treating back pain, 40 patients were given a treatment with magnets and also a sham treatment without magnets. Pain was measured using a scale from 0, no pain, to 100, extreme pain. After giving the magnet treatments, the 40 patients had pain scores with a mean of 12.0 and a standard deviation of 2.1. After being given the sham treatment the 40 patients had pain scores with a mean of 10.4 and a standard deviation of 2.5. Part A. Construct the 95% confidence interval estimate of the mean pain score for patients given the magnet treatment. Okay, so we're looking for the magnet treatment. So what it said up here about the magnet treatment was, after being given the magnet treatment, the 40 patients had back pain scores with a mean of 12 and a standard deviation of 2.1. So we've got 40 patients in our sample size. So our sample size is 40. Since this number, the 12 and the 2.1, came from this sample, that means that the 2.1 and the 12 are sample statistics. So they gave us X bar is 12.0, and our sample standard deviation is 2.1. Because they're using a sample standard deviation, this is really saying that sigma is unknown. And if sigma is unknown, then we need to find a t-score. Okay, so they're asking us to make a confidence interval, which would be x bar minus e less than mu less than x bar plus e. Well, I've got my x bar, but I need to find e. And e is a t-score times s divided by the square root of n. Well, I have s, that's 2.1. I have n, that's 40 patients. I need to find t. And I'll need two things to find t. Number one, degrees of freedom, which is n minus 1. So 40 minus 1, or 39. And alpha, which is 1 minus your confidence level. So that would be 1 minus, okay, our confidence level is 95%. So 0.95 or 0.05. This alpha is in 2 tails. Okay, so those are the two numbers that I need to find my t-score. So I'll go to my table, and I have a alpha, which is 2 tails, so this is alpha right here, of 0.05, right there. So I will be in this column. Then I need to go to my degrees of freedom and find 39, which is right here. Okay, so keep pulling this down and find where they intersect. Right there. So my t-score is 2.023. So 2.023. Well, now I can find my margin of error. So this would be 2.023 times 2.1 divided by the square root of 40. And this will give me 0.672. Okay. Now that I've got my margin of error is 0.672 and my x bar is 12, I can plug that back into my confidence interval. So that will be 12.0 minus 0.672 less than mu less than 12.0 plus 0.672, or 11.328 less than mu less than 12.672. And that is what they were looking for. That's your confidence interval for your magnet treatment. Now we're going to do the exact same thing, except for now we're looking for a confidence interval for the sham treatment. So we need to go back here and find out the information they gave us for the sham treatment. So after being given the sham treatment, the 40 patients had pain scores with a mean of 10.4 and 2.5. Okay, so we have 40 patients. We have a mean of 10.4 and a standard deviation of 2.5. Same thing, since these two numbers came from the 40 patients, which is a sample, 10.4 and 2.5 are sample statistics. So X bar is 10.4 and S is 2.5, which is saying sigma is unknown. Therefore, I've got to find a t-score. Okay, so a t-score, I would need two things. One, degrees of freedom. In minus 1, we've got 40 patients minus 1, so 39. And alpha, which is 1 minus our confidence level. Our confidence level is 95, so 1 minus 0.95, which would be 0.05. Remember, this is going to be the area in two tails. So we go back to our t-score chart, and we'll find the same thing. Okay, area in two tails, which is alpha. 0.05 will be in this column right here. We'll go over here and find our degrees of freedom of 39. Where they intersect, well, that is 2.023, just like the last problem. 2.023. Now I can find my margin of error, which is a t-score times S divided by the square root of n. So 2.023 times 2.5 divided by the square root of 40. And this will give me 0.800. Okay. Now I've got the two things I need to make my confidence interval. So that would be x bar minus e less than mu less than x bar plus e, or 10.4 minus 0.800 less than mu less than 10.4 plus 0.800, which is the same thing as 9.600 less than mu less than 11.200. And this would be my confidence interval for the sham treatment. We go back. This is my confidence interval for the magnet treatment. Okay. The last question is, compare the results. Does the treatment with magnets appear to be effective? Okay, so if we compare them, sham treatment we had a confidence interval of 9.6 less than mu less than 12.2. For the magnets, we had a confidence interval of 11.328 less than mu less than 12.672. Now remember at the very beginning, they said right here, we're using a scale from 0 no pain to 100 extreme pain. So here's our scale. 0 to 100. 0's no pain, and 100 is lots of pain. So the higher the number goes, the more pain you're in. So if I was going to choose the sham treatment or the magnet treatment going in for back pain, I would want less pain. So notice the magnet treatment is 11 to 12, whereas the sham is 9.6 to 11, which is lower, which in this case would be less pain. Magnets would be more pain since they are higher numbers. So does the treatment with magnets appear to be effective with curing your back pain? No, it is not.